Okay, let's get going. I figured that he's not a native speaker. A lot of you aren't from, as I've been told, Native America. So I should tell you what this means. Motherhood and apple pie is an American colloquialism. It means principles or values with which few disagree. So it's, modularity's like that. Now the problem here is that I'm not a mother, at least I'm told I'm not, and I don't like apple pie, really. So what does that mean with modularity? Well, modularity, my definition of modularity, and I get to define it because I'm giving the talk, is that modularity is the ability to view everything related to a particular concern, whatever you're working with, on one screen. That's my measure of modularity. Now you can look at what this means in general, what other people define modularity to mean. And they say it's the division of a system into a set of independent modules, where modules represent a set of related concerns and communicate in some loosely coupled fashion. I took a whole page of definitions and tried to boil it down into something that I could put on one screen that could still be readable from the back of the room. Well, my claim with either of these definitions of modularity is that absolute modularity is impossible. And I should really explain this claim. Let's see, modularity in the static sense, just having a fixed view of the system, is not going to give you what you want in terms of modularity. Another way of saying it is there are many different, very different in some cases, concerns, and attempting to be modular for each of those concerns, which is what you want to do when you're programming, or when you're debugging, or when you're maintaining code, or when you're going back and adding new features, or trying to find a bug. Attempting to be modular for any reasonable subset of these is not going to work. It's not going to be possible. So just like motherhood and apple pie, modularity is all about how you achieve it. To demonstrate this, I want to take a few examples from the work I've done over the past few years and show you the modularity problems I've been having here. So the first one's going to be a bit complex, but hopefully you'll understand the problem by the time I'm done. And that's code bubbles. So normally at this point I do a real code bubbles demo and do it live, but you probably want to get to a coffee break. And I tend to get carried away when I'm giving demos. But I'm happy to give them later on in private or to any group that wants to see them. And I have it on my computer, and you can download it on your computer as well. So what I have instead is I have a video. And I'll try explaining what's going on here. So this is code bubbles. You get a large area where you can work. Here what I'm doing is I'm typing in parts of a name in order to get a method up. And this is, what's that method? Oh, I can't tell. You can't tell either. But anyways, I'm clicking on initialize here. I'm going to hit F3 to bring up the bubble. That's the code for that. I can bring it down here. I'm going to click on the bubble, on the name start here, and hit F3 to bring up the definition of that. But that's a system routine. So instead it brings up a bubble showing documentation. And you have bubbles for documentation. You have bubbles for errors down here. You have bubbles for code. All are editable. You'll notice that there's some elision going on here. It doesn't show you all the code. Where can I see elision? These bubbles are, these code is fairly short. Here I'm clicking on the definition. It's a virtual method. It's going to bring up all the virtual calls for you, not just the definition. I can bring those bubbles out of that bubble stack, which is the result of having that. That one's irrelevant to me. This one I'm interested in, so I'll move it up out of the way. And then the last one there, I'm not interested. I'll move that out. I'll rearrange the bubbles myself, and I'll just set up my screen the way I want it to be set up. Now you can form groups of bubbles. You can, if the group has a label on top, you can label your groups, say what that is. You can move bubbles in and out of groups, whatever you want to do. Now I'm going to move to a new area of the screen and work on something different. Here I'm going to click on an error message down here. I'm going to go in this bubble up here where the error occurs. It's a warning actually. And I'm going to start typing. Now you might see that there's a little squiggle underneath that. We'll get back to that, showing where errors are. Just like in Eclipse, we're a little faster. Although we're using Eclipse. You have annotations over here for errors. And we're essentially typing. Notice I just keep typing, and it wraps around automatically. So the display automatically wraps to keep the bubbles small. But if you, when you're done, if you expand the bubble, the wrapping goes away. If you compact it again, the wrapping will come back. It's all dynamic. We'll move over here where we have a fixed display we set up before. This is something we were working on before, trying to understand, in this case, how gravity is computed. And you can go back and work with these different things and go back and forth between it. This isn't done. We're doing debugging here, too. Good demo. So here we're starting the program. We have a console. We have the stack display. We have a debugging history. We have performance analysis, although we don't run the debugger long enough to get anything down there. Notice you get the code here. You get the stack here. If you step in, you get the new thing connected with a line. So your stack grows. You can have it grow horizontally. We've recently made it grow vertically. It seems to make more sense. The history shows where you are. And you get the whole sense of what's going on in terms of debugging. You can edit the code here. You can edit the variables here. It's all changeable. It gives you a nice view. Now is it done? I think now it's done. OK, so I had a problem. Red doesn't show up very well, does it? Sorry about that. But the red squiggle's red, so I had to put it in red. I think that's the only red I have. The squiggle was sometimes out of place. Normally it was fine, but every now and then it would be under the wrong text. It would be in the middle of nowhere. And I had no idea why. And this was while I was typing characters in. This was the problem I had to fix. This was the concern I had. I wanted to fix that squiggle. Well, character input, you think it should be pretty easy, right? You're just typing characters. It's a mess. The overall scheme here is you update the editor buffer, so somehow I get the notion that there's a character coming in, and I just change the buffer to put that character in the middle of the buffer. It turns out there are other effects you might do. You might do auto indentation there if it's you end up typing case, or you type a brace. Let's see. There's auto indentation. You might delete text because you had a selection when you type the character. In any case, it has to compile a code again after that character's typed, report errors. It has to update the underlying structure so it can do the syntactic highlighting correctly, semantic highlighting in our case as well. And then it has to repaint the screen, adding that character to it. Well, code for this, well, we think it's modular. Everything's separate, and there are lots of concerns. This is most of it. This isn't all of it. There's some event dispatch code that's hidden in Eclipse someplace. That actually is getting the character. Actually, it goes out to our code because we steal the mouse button 3 for code for bubble manipulation so that it never gets shown. Or maybe we steal button. Yeah, we steal button 3. It never goes to that. So we have our own event dispatch plugin into the Swing plugin. Here's the actual code that we have for handling the event. Just update the selection. That adds the character to the buffer remove selection. There's a call to do that in Eclipse. Handle auto indent, handle auto completion. If you have to put up an autocomplete menu at that point, maybe you do, maybe you don't. Or if there is one up, you want to fix it up. It turns out that when you insert the character, Eclipse has a buffer that you're inserting, or Swing has a buffer you're inserting in, and that buffer, after you insert the character, generates events. So there's a document dispatch, which magically generates these events. That updates other editors. You might have noticed. Well, you probably couldn't read, but you can have 2 editors which are the same, and if you type in one, the other will update automatically. Well, that's where this is handled. It also updates Eclipse. We're using Eclipse on the back end to handle all the compilation, so that we have to tell Eclipse this character got typed in, or this change was done. So we have to go update Eclipse. Now, what I don't have up here is the code that sits in Eclipse. Well, we have to get to Eclipse first. It's running in a different process, and we're using PubSub. We're using a message bus to talk to it. That's not up here either. And Eclipse magically adds it to the buffer, tells it to recompile, gets the, and that's all happening in the other process. Eventually, Eclipse returns, it finishes the compilation, and when it does that, it reports errors. There's an Eclipse error reporting mechanism. We get those errors, and we send them out over the message bus. We get the errors coming into code bubbles, and we update an error set. So we maintain our own version of what the current list of errors are in code bubbles. When these are updated, we send out notifications. So we're using Observer here. And there's something in the editor which, when it gets an error notification, updates those annotations on the left. The stop sign, the error sign. I guess there's an E or something like that. It also updates where the squiggle should be. So it updates, finds the element if there's an element associated with that, and puts a flag saying this should be squiggled. Eclipse also sends back a new syntax tree after compilation if it's changed. And in that case, we have to update the semantics of the element. So we have to change this saying this is an if, this is a block, this is a variable definition, this name's a variable, things like that. So we can highlight them, do some semantic highlighting. There's an independent code running in the AST thread, an AWT thread, swing thread, that handles repaint. And some of these changes are going to request a repaint. So there's a whole bunch of repaint requests that come in based on updating the elements here, document dispatch, changing things. These get merged somehow, and eventually the code for handling the display comes in and computes a layout and repaints the text. And hopefully the repainting of the text handles the squiggle. Now the actual code for squiggle is very simple. There are two triggers for it. One, if you get a problem update, then you lock the file, important. You call update problems, you unlock the file. When you update the AST structure so that things might have changed, elements might have been rearranged, you clear all the problems that were there, clear all the squiggles, update the tree, and then based on the set of problems, update all the squiggles. Update problems. The actual code is update problems. It's about 30 lines of code. It's complex only because it's maintaining the set of problems incrementally. In this case, it clears all the problems first and updates them, so there's nothing incremental. But in this case, it's just doing an update, so it does everything incrementally. It removes styles for non-existent problems, and it adds styles for any new problems. And then there's the independent code somewhere in the text drawing, where if it checks if it's squiggle, and if so, it draws a line underneath it with a squiggle paint style. So that's pretty simple. The problem here is that what I just showed you, what I just told you, is a simplification of what actually happens. In order to do this, I couldn't fit it on a slide. But I have this, and let's see what we can bring up here. Well, we tried. Come on. There. Okay, so this is the high-level view. And you can expand these and see that there's some internal magic going on. No. Just go make it bigger. You zoom in. Zoom in. That readable from the back, sort of? Okay, good. That's a thumb up. I can't even see the thumb, so. There's some internal magic going on that handles the type in key event. We call event dispatch. Our own event dispatch gets called, and it eventually goes back and calls that event dispatch. There's an asynchronous follow-up event, so we'll just expand everything here. And let's see. You call node active. Does that? It forwards it to swing. There's some internal magic inside swing. And eventually, it calls the action performed on the default key action. This does the key replace the selection, which is updating the text. Here's the document insert. It calls handle insert. It calls document and locks the file. Comes through. It calls element insert string eventually on the element buffer. And then it replaces it takes whatever structure was there on the line you just typed and says, we don't know what the structure is, let's replace it with line elements. Well, that's one place the error could have occurred. It keeps going, it gets this event, and it changes the annotation area as well. That's the thing on the left. That involves error, so that's another place problems could occur. It may generate repaint requests for lines. That's important because we get to repaint later on. It does a highlight context. It checks the position of highlighted elements. That affects the screen. That can affect the squiggle as well. So we put that in red. Updates the cursor position. Calls the various event listeners. Calls the undo event handler. So that gets recorded there. Hopefully that doesn't cause any problems. Eventually unlocks things. And it also, after it's typed in the character, might call auto indent. Well, that might change the position of things. It might screw up where the squiggle occurs. Maybe that's the problem. So we highlighted that as well. And that's the single sequence of things. Now, there are a number of asynchronous follow-up events. that occur here. There's repaint handling. So repaint's in a different thread. This is all working in one thread. The repaint handling's in another thread. It locks the fragment. It computes the sizes of all the text things there. It sets the position and size for each element. This is another place things can go wrong. It draws each element in a specific location after it's set the size. Well, the drawing is obviously wrong because it's putting the squiggle at the wrong place. Eclipse generates an edit error event. You know, so somewhere up there we sent the thing to Eclipse. Eclipse generates an error handler event. We update the problems and then call problems done. We said that. Here, Eclipse generates an elision event. This is when it's figured out the aosd. It gives all the priorities on the various branches there, so you can do elision. That's why it's called an elision event. We have a fragment elision updater, which tries to update this, but it doesn't run here. Instead, it runs in another thread using the thread pool. So it's running asynchronously as well, independent of the event coming in from Eclipse. So here's that running. And it can change any structures. It can update the element hierarchy. It can restore problems, elisions. All these things can also cause problems. The error updater runs in a swing thread as well, in the swing thread. After we finish it, it runs in a separate thread, and then it runs back in the swing thread. And it determines the position associated and sets the error annotation. So all these things here run asynchronously. I have no idea what's going on when. They run in different orders at different times. They might be running at the same point. We don't even cover here the fact that it's going out to Eclipse through the message bus, the fact that we don't actually display windows. We have an interface there which can freeze the windows and create a bitmap, and then we have to remove the bitmap at times and put it back. Swing does double buffering, so what you actually draw may or may not appear on the screen at that one point. And you have multiple overlapping fragments that can do weird things. You can have text overlap. There are lots of things that come into play here. So you can see it gets a little complex. I was surprised after I basically did this to figure out what was going on, and after I did that, I was surprised that typing a character actually works, and works at real speeds. Well, I can claim, and you can debate this, but the code is modular. It's nicely separated. You have separation of concerns. I showed you the different color things. The dynamics of the code, however, are not. What's going on here involves code from many different things, all the interactions, which is more important? Well, if you're writing the code, maybe the semantics, maybe the modularity of the code is important. But if you're trying to debug it, if you're trying to fix things, the dynamics are more important. And that's where you want your modularity. So modular review for squiggle, what we want here, in order to do this debugging, is we want the source code for all the relevant routines. Think about all the routines, all the things we had in red, those are potentially relevant. We need to be able to see that source code. We need to understand how they're related. So what we really want is we want a view of what happened at runtime in terms of these codes. And it's not a single view because this is non-deterministic. It's multiple threaded, it's a multiple process. So we want to have a view of what happened when it succeeded, when it was right, and a view of what went wrong, what was different when it was wrong, so we can correlate that back to the code. And if we had this view, we'd have a nice modular view of the dynamics that we could then find the bug. Now it turns out I never found this bug, it just went away. So something else I fixed this, which I can't explain what went wrong there, or where the actual problem was. So some of the problems we had here, first of all, there's all this black box code. Eclipse does magical things. We have no idea what it's doing at times. We try, but Swing does magical things. You have several separate interacting processes, timing considerations. There's unknown control flow. The multiple threads run independently, can do whatever they want. The callback orders on the observer pattern, I think they're deterministic, but I have no idea what they are. And my code has to not assume they're in any particular order. And there are a lot of dynamic issues. We want the modularity here to reflect the dynamics. So that's the first problem we had. Next problem, next code I'm writing. I have a sign outside my office. Actually, I have a picture frame outside my office connected via Bluetooth to a computer in my office. This is an intelligent picture frame, or an intelligent sign as I call it, smart sign. And it automatically updates to say what my status is. So it detects if I'm in my office by checking if it can see my phone via Bluetooth. So it just sees if the phone's available via Bluetooth. If it is, it says, I'm close enough to my office so you can say I'm in my office. If it can, it says I'm out of the office. Good approximation. It detects if I have a visitor because it has a motion detector aimed at my couch where all the visitors sit. And if the visitor moves enough over time, it knows I'm with somebody. It can note that. It knows if I'm on my phone. I have a nice old-fashioned phone. I don't use this for anything. And it has a circuit, some electronics there which detects if the phone is off the hook. And that's how it detects that. If I'm out of my office, it knows it has some sense of where I am because it can read my Google Calendar and look at the events and know when I'm going to be back or know where you can find me at that point. And it has a set of rules to say for any set of these circumstances what should be put up on the sign. So the sign automatically updates. I don't do anything, but everyone knows whether I'm available right now, or whether I'm on the phone, whether I'm with somebody, if I'm out of the office, what room I'm likely to be in, things like that. If anybody wants to commercialize that, come and see me. The code for this is a little bit of a mess. It was sort of thrown together pretty quickly over time, using whatever tools I had. So there's the various sensors, the phone circuit, the motion detector are connected to an Arduino sitting in a box. That's connected via USB to a computer where it's running a little Java program which monitors that and determines, based on the sensor input, whether I'm actually on the phone's off the hook for more than a certain amount of time, or whether I actually have a visitor. Now I walk by my couch to get to my desk. So it's going to see me walking by there occasionally. So it has to have some heuristics as to when you actually have a visitor. It has to be there for a certain amount of time. You have to have so much movement over time. This thing takes care of all of that. You have a controller, which does we'll get to that. You have something that talks to the Google Calendar, gets the calendar events for the next day, and correlates them with what's going on. You have to get sort of in advance. You have another tool where I can say, for now, I'm going to be out for the next hour. Put this message on the sign and just throw it up there. You have another tool which actually takes the text that the rules say the sign should have in it and generates a PostScript file with that text in it and then converts that PostScript file into a JPEG file so that it can go to the picture frame. You have Bluetooth, which is a C program sitting on another machine actually than the controller is. Same machine the Arduino monitors. I don't have that many machines in my office. And that talks to the picture frame. It also senses the phone, so there are a number of Unix Bluetooth programs I use there. There's a picture frame. I have no idea what the picture frame is running. I assume it's some version of Linux, but it's running some code there. And I've had to figure out how to make it so I can add pictures and not fill up the memory. Add signs and not fill up the memory. There's the controller which does all the coordination. And then there's this data file. Half in memory, half on disk. It automatically updates, which are all the rules you have for what to put up on the sign, depending on all the other conditions. Well, the code may or may not be modular, but where I'm interested in modularity is what I'm doing with it. Well, what's the concern I have at this point? Is it modular for this particular concern? Adding new events. I wanted a not-in event for some reason. Normally I have an away event and a stepped-out event. So the first 5 minutes I'm out of the office, it's like I'm just going to the bathroom, because as you can see, I drink a lot during the day. And you can say that. But if I'm out for more than 5 minutes, it's likely I'm not going to be back for a while. So I had those as two different things. But I wanted one which is just, I'm not in the office right now. For another reason. Adding that was easy. It was very modular. The system makes that adding easy. Adding the calendar events, going out to my Google Calendar, what was sort of in between. I had to understand Google Calendar. I gave up and tried the earlier version of Google Calendar because you don't want to try doing OAuth from a non-web application. I don't recommend it. And the earlier version didn't do that. But once I got that code written, adding the rest into the controller was maybe changing 5 lines in 3 different routines. So it was fairly modular there. If I want to add a new sensor, say I want to add a sensor saying whether my door is open or not, or I want to change the motion detector to be an infrared sensor, ultrasound or infrared sensor to be more accurate in terms of whether people are in my office right now. This is a real mess because you have to program the Arduino and get that. You have to then take the output from that and program the Arduino checker, different language, different module. And then you have to go and add that event, all the stuff you did here, to that. And then you might have to also change the data format file depending on exactly what you're doing. So doing something like this is in no way modular to the system. The obstructions, right? Not objections. Obstructions to modularity in this case are, you have externally imposed modularity. I can't run code, arbitrary code on the Arduino. I have to run Arduino code on the Arduino. They only made Bluetooth available on my 32-bit computer, not on my normal 64-bit computer. So I had to use that to do Bluetooth. I have multiple machines, therefore. There's external code. I didn't want to write Bluetooth code. I have to figure out how Bluetooth works. So I use OBEX FTP, HCI tool. It turns out I also use SDP tool, 3 different Linux programs for handling Bluetooth. And then I had to talk to Google Calendar. And there's some interface there, but it's doing some magic at some point. Part of the program is data. How do you modularize the data? Data is just as important as code in this case. It's passed between applications, and it's representing the rule set. Okay, so that's the second application and where I have problems with modularity. Third application, I have Twitter data. Let's see, I've been collecting Twitter data for about 16 months now. It's a small set, about 550 million tweets, all with geolocation information within the continental US. And I wanted to, it's nice data. It was for a course originally. Students still come to me and want to use the data. I didn't want to have to get their data manually. I wanted to put up a website that let them get their data. So we did this website. This is very primitive. I'm hoping to get some students to fix it this summer. But here we're going to search. And we're going to type in tsunami here and find all tweets that have the word tsunami in the continental US. We cut out some space there. We can sample and see what they look like. We can group it by days, weeks, whatever. So here we're going to group it by months. Again, we cut out some delay there. There's a bug in the system. It doesn't update things that are zeros. We're going to set the statistics so that the statistics are sort of meaningful in this case for the display. And now we're going to go over the display, and you can see things get red at times. We're indicating a high level of tweets on that. Orange is sort of moderate here. This is the week of August 27th. It turned out there was a tsunami alert in California that week. There's a big tsunami alert at the end of October. At the same time we were having a hurricane, snowstorm, whatever, on the East Coast, Sandy. And people were tweeting saying they have a tsunami here and superstorm here. And there's another one in February. So you can correlate that. You can correlate hurricanes. You can correlate the incidence of the flu and see how it peaks. Lots of little fun things. And this is what the students are doing. So we're trying to put up a website for this. I think it's done. So there's my other control. Code for this is pretty much a standard web application. You have some data you want to get. We're getting it from Twitter, so there's some magic Twitter here, and there's a magic streaming library. We have our own streamer code, which just reads that and dumps the tweets into individual files. So one tweet, one line per tweet. We stop after 1,000,001 tweets and off by 1 error for each file. And so we have all these files with 1,000,001 tweets in them, and each time it fills up, we start a new file. And that just goes into the file system somewhere. We have another routine which we run daily, if we remember to, that reads the latest files, any that are complete, and actually takes the latitude, longitude, those are what they're called, and encodes that as zip code and congressional district within the US, and then inserts all this into a database, Postgres database. And then we have a web application that just reads that database, typical web application. We happen to write in Node.js because I was told I had to learn Node.js because I'm supposed to teach it this semester. And then you have HTML pages, and each HTML page has a script page going with it, and each HTML page also has a CSS page going with it. How do you modularize something like this? Well, the problem, you have all types of problems. But again, I want to consider modularity in terms of what you want to do. And one of the things I want to add are support word comparisons. So it's nice to be able to look at individual words, but some of the students want to do things like compare the number of tweets for Romney versus for Obama over the course of the election, or compare the various Republican candidates, or anything else. How do you do that? Well, that would be fairly modular in that it's just a separate web page, the same database. You don't have to change any of the data, anything before that. You just add a new web page and the corresponding JavaScript and CSS. Now, separating those three, in some sense, lets you have nice separation of concerns, but if you ever want to change them, you're actually looking at all three at once and changing all three at once. And it's not really as separate as you'd like it to be. But that's modularity in web applications. I didn't see any papers on that, but it would be good to have that. Their separation of concerns and modularity are sort of at contradiction to one another. The other thing we have to do is normalize the tweet counts. It's often the case, this happens in certain ways. One, it's often the case that California becomes red long before any other state. It's just there are more people in California, and we're not normalizing it by the population. New York and Texas are similar. The other thing is Twitter seems to be giving me about twice as many tweets now as it was giving me a year ago. So the statistics look a little skewed that way. I want to normalize all this. I haven't done this yet because it's not in any way modular. It requires going back and changing the database, changing all the data I have. It means changing the program that reads the tweets and updates that to get and update this information in various ways. It means changing the back end, the web server, to do the normalization and send normalized statistics out. It means changing the front end so the user has a choice of whether they want normalized or unnormalized statistics. And it's just spread throughout the whole system. I'm not looking forward to doing that. How do you make that modular? So here are the obstructions to modularity. One, you have multiple programs. We talked about that. Messages are part of the system. Messages not only between the web server and the web clients, which are using web sockets down here in JSON. And so those messages and what's in them is important. I guess those are the main messages that are going back. The database is a big component. If you want to look at modularity of the system, you can't just look at the code. You have to look at the database, the data schema, database schema. That's just as important to modularity as the actual code. And the web application, as I said, has its own constraints. And you have different front end, which is very separate from the back end. You're supposed to separate all those, separate files. Makes it a mess. Okay. I like code. Next thing, as you said, I do code search. Again, demo. Do a demo on the web. It's a website. So let's see if we start this. No. This is supposed to start. Well, if you can't do it that way, we'll start it this way. Okay. So what we're doing here is we're typing up here cardinal number. We want to find a routine that does cardinal numbers. We're giving it a signature string convert of int. We're typing here 17 should yield the word 17. And we say find it. And now we cut. Because this usually takes 30 to 40 seconds. I didn't want to wait that long. So what happens here is it goes back, and about now it should give the result there. And what you get here is you get a whole bunch of all the code that can find, in this case GitHub, which actually does conversion of a number to the English form of that number. If you want it in some other language, you can probably type some other language and it will work as well. And you can see all the code there. Now the way this works is, you can also reformat it. The way this works is it takes these keywords you give it up here as a description, goes out to a code search engine, in this case GitHub, finds all the results that come back. Takes the first couple hundred results. Each of those specifies a file. It's looking for a method. It says each method in each of those files is a potential candidate solution. We're going to take those candidate solutions and we're going to transform them. We have a set of 40-some transformations. We're just going to keep applying those transformations again and again. after we apply, we get a new solution. We can then apply different transformations to the new solution. And we're going to do this until we can't apply any more transformations. We're going to take all the solutions that result and do a dependency check on them, add any fields they need from the original class, and any private methods they need from the original class in order to compile. Then we're going to take the ones that actually compile, and we're going to compile those and run them with JUnit against the user's test case. And the ones that actually pass the test case, that's what we report back. So it's a fun little system. Now we can go here. So there are lots of different modularity issues here. The one that concerns me these days is the transformations, because I like adding new transformations. I'm essentially simulating how the programmer uses code search. We tried to make it very easy to add new transformations. We have a transformation base, which has some of the code. We have Java transformation class, which has the bulk of the code that's needed. And then the user gets to define their own transformations. And you can define any one of them. And all you basically do here is you define a little preface, which says whether it's applicable. And then you define an editor of the abstract syntax tree, which takes a node and says what it should change it to. And all the other support codes in here. So it makes it very easy to add transformations. You can say the transformations are very modular. They average about 300 lines of code. This is over the 40 different translations. The simplest ones are 135. Even the most complex ones, and I should describe what they do. The simple ones do things like change the name. They have some name in their method. You wanted the method to be called convert. Just change the name of that method. Well, that has to change all references to that name in case it's recursive. So it's not trivial. Others are a little more complex. Drop arguments and replace them with assignments, logical assignments. And then the others are really complex. Find a line code that computes a value of the return type, the type you want to return. Now do a backward slice from that point until the only free variables are variables of the parameter types. Extract that code into a new function and make that new function be your solution. So these are, even with that, these are fairly easy to write. The longest one's 940 lines, and this includes all the comment lines. So you pretty much divide that in half, or at least by a third, to get lines of code. They're independent. You just write them, and it automatically configures them into the system. They're automatically, the application automatically uses them. It's detected. Adding a new transformation is trivial. I can add a simple one in under an hour, a moderate one in 2 or 3 hours, basically because I have to think about exactly how to edit abstract syntax trees. And the complex ones maybe take a day to try out. So in some sense, I've achieved the modularity I want in terms of transformations. The problem here is that the transformation sequence, you apply a transformation, you get a new solution. You then can apply transformations to that to get new solutions. The sequence blows up. There are a variety of reasons for this. The typical one is you have idempotent transformations. So you have A, B, and C, and you can A, B, C, D, E, or A, B, C, D, E, F, G, H, I, J. And they can be applied in any order. Well, it'll try all different orders. It doesn't know any better. They're all different. And then, 10 different ones. You get 10 factorial different solutions you have to generate. The program doesn't terminate. So while the transformations themselves are modular, the transformation process, the way they're applied, is not modular. Let's switch back to something where I can change slides. What we really want here is we want to have modularity in the transformations itself. I like writing transformations easy. But we want modularity in the code, the heuristics that guide the transformations. And we need to do this while keeping the transformations simple to write, while not knowing what the set of transformations is. So how do you write the heuristics without knowing what the set of transformations are? We have to keep the transformations independent of one another so we can bring them out, add new ones. Make it easy to add new transformations and still have decent heuristics. What we wanted to modularize, or what we want to modularize in addition to the transformations, is the transformation dynamics. And I haven't figured out how to do that yet, but I'm working on it, I think. Maybe I'll do that this afternoon. So here are the obstructions to modularity, or the transformation dynamics are not explicit. It's hard to modularize something that's not there, not in the code. explicitly. It's encoded right now in individual transformations in their checks. If this is not the case, then don't do this. The heuristics are spread throughout. It's difficult to get a modular view of them. It's difficult to understand what's going on. This is all done because the transformations have to be independent of one another. And you essentially are ending up with conflicting modularity concerns. You can't modularize both things. Okay, so what have we learned? First, I have lots of fun coding. Here you can see me in my office, and if you look carefully, you can see 1, 2, 3, 4, 5, 6, 7 displays. I usually have 8, but my laptop isn't here today, that day. It was home preparing these slides. But I do lots of coding and have fun that way. But what we really learned is modularity, and what is modular is in the eye of the beholder. It depends on the application for modularity, what concern you're looking at, as much as what the code looks like, how it's coded, what's compact, or what's in one place, or what not. We've also learned modularity in today's systems where you have these multiple threads, multiple processes, enforced division, complex going on. It is difficult. And there's several reasons for this. One, you often have multiple languages that's enforced upon you. A single solution like aspect-J doesn't work if you have to code part of it in C or in JavaScript. You're worried about what's this? Processes, threads, multiple threads, timing dependencies. These come into play. Looking at the dynamics. You're looking at communicating processes, communicating programs. These force modular decisions. It's hard to do modularity when you have two separate processes, programs that you're writing in that have to communicate and interact with one another. Data is an important part of the system. You have to consider data modularity as well as code modularity. The dynamics. I was stressed. A lot of the issues I'm going to look at are dynamic issues. What happens at runtime is important because that's what I'm trying to debug. That's what I'm trying to fix. That's what my concern is. How do you deal with modularity and dynamic issues? And the last thing is there are a lot of ways of looking at a system. And you want each of those ways to be modular. Okay. So the challenge here is that there's no static modular view of a system. aosd, or abstract-oriented software development, is too simple and doesn't address a lot of these issues. You've changed it to modularity. That's good. No language-based solution will work because you have to have multiple languages. And some of these languages, like the database, aren't really languages, or CSS aren't really languages in the sense you want to consider them. The other challenge here is modularity depends on the circumstances. Different static views imply different modularizations. Different dynamic views imply different modularizations. You can, if you look closely, you see the cat there. I like that. So modularity, so the obvious solution here is to create a system that gives you multiple views of the so you can have your different modular views of the system as you go. You have a flexible system, one that can transform itself. Modularity becomes a function of the view rather than a function of the code itself. There are many systems that people have been trying to do this for quite a while. You can view the idea is you want to view the system, view the modularity in multiple ways here. So that's what you're trying to achieve. People have been doing this for a while. It's done successfully all over the place. Most UML editors you'll see out there have a single underlying representation in all these different views, and you can edit things in lots of those different views. And we've been working on this for quite a while. We started with Pecan. Now it looks a little primitive because this is 30 years old. But you have multiple views. Here's the editor and editable views. Here's a flow chart. That was read-only. Here's stack view. That actually is editor. This is stack view. It's editable. This is a scoping view. It might have been sort of editable. Some things there were editable. Others weren't. This was nice, but it had a limited set of views which were actually editable. And having read-only views doesn't give you modularity. It was very dissatisfying to try using it and have these views up there and not be able to change them, not be able to work with them. So we next tried to make everything editable. And we moved on to Garden. This is about 5 years later. And here you can see a nested flowchart language. They were big back then. Regular flowchart language, a data flow language, and a FSA language. These are all editable. And they could be mixed and matched and coded that way. The problem was you could only view each particular thing in one way. You couldn't go and view one thing in a different way. But it was nice. It showed you could do that. We then moved on to Field, which was just Pecan applied to the real world. So this was actually used. But again, you only really had editors which were editable, and all these different views, data structure views or call graph views, were read-only. So again, it wasn't that satisfying. Our first attempt to merge, get away from this was Desert. Desert let you create, broke a program, which was in files, down into little fragments. So a method could be a fragment, a class could be a fragment. You can have nested fragments, so the methods in a class were fragments. And then you could create files. This is an example of a fragment file. I don't have that many images back from it. By taking fragments from multiple files and merging it into a single virtual fragment file. And then that virtual fragment file is effectively your modularization, your view of that particular concern of the code. Now, we didn't just limit the fragments to be code fragments. You had things like UML diagrams you could intersperse with the code and put in files, documentation, and lots of other things. Now, this didn't catch on. A couple of reasons. One, it's a little, files were probably the wrong mechanism to use there. I also, you might recognize this is FrameMaker. Anybody use FrameMaker for code editing? It's a little bit heavyweight. It gives you nice styling, but it was a bit overkill. So a lot of people have tried to actually achieve the ultimate goal of having a single representation and then being able to create multiple views of that. One of the earliest was one of my PhD students, Scott Myers, who tried to use SPGs, semantic program graphs, as a common representation for data flow and control flow. Now, he thought he succeeded, but my reading of his dissertations was, you're never going to be able to do this. It's never going to work. And that was the reading I took out of it. I didn't tell him that. But then there are a number of things that were like sheets and visual age, which gave you views of individual components. And more recently, there have been a number of attempts that try to give you multiple editable views of a system. These don't and never will and won't work. The database community found this out a long time ago. They call it the database view update problem. Views are very nice. They're the results of queries. You'd like to be able to present them to the user rather than the raw data. But the user would like to edit them. The problem with editing these views is an edit to the view is ambiguous in terms of what that means to the actual database. You can't have a single representation that supports all views. You have to very much restrict what you can do if you want to be able to edit the views. The program view update problem, doing this for programs, is even worse. The semantics of databases are at least well understood and confined. Programs have huge semantics, much more complex representations you're dealing with. If you can't solve the simple case, you're not going to solve the more complex case. So what do people do here? Well, they either severely restrict which editable views are allowed. This predetermined set or strong restrictions. You don't get modularity that way. Don't get the views you want. Or you make it so you can create new views, but then you have to explicitly define editing operations for that view. Well, that means that if I want to define a modularization, a new view that gives me this modularization, I have to do a lot of work to define all the editing operations, and I'm not going to do that. Programmers are inherently lazy. And therefore, that's not going to give me modularity. Or you use read-only views. And we learned 30 years ago that this is totally unsatisfying to the programmer. You don't get what you really want there. So what I propose instead, as a potential solution, is something you've already seen this talk. And I call it virtual modularity. And what we want to do here use my definition of modularity. We want to create a modular view of the system. All we have to do is find the components of the system and make them fit that relate to that particular concern, to a particular concern, whether it's static or dynamic, and make them fit on the screen all at once. Now, I'm not changing the underlying structure of the system. I'm not changing the underlying files. I'm just creating an editable view of those things. And where we've seen it is in code bubbles. This is the view we ended up with in code bubbles. And as I said, this is what I need to understand. All the code I need to understand the concern of how gravity is computed using multiple threads. And you have a master here, and then you have, if I can read this, computation, compute local gravity for, I can't read it. Well, you have the base case, and then you have the cases. Here's the finisher, what's called after the gravity is computed to merge things back up. And basically all the code's here, and it's using a number of techniques to fit it all on one screen. Now normally I put it on my double monitor, two 24-inch monitors, so this is a little compact and a little bit of a simpler case. But two 24-inch monitors gives you a lot more. But here it's using elision. You can see the dots at places to hide things that are not particularly relevant. It's using little code, compacting the code as need be, only showing what's actually needed there to get the modularity you want. So is this a modular view? It satisfies my definition of modularity. It might not satisfy other people's definition, but from the programmer's point of view, from a practical point of view, where I have to address a particular concern, my concern here is that the gravity computation is nicely parallel for computing gravity, but the parallelism breaks down totally when it has to add up all the gravity, and I wanted to figure out why. So this was an actual concern. From my point of view, it is a modular view. It gives me everything I need all in one place, and I get to see it. Now, Code Bubbles tries to enhance this modularity. It has this notion of working sets. That's that dark area on the screen we were in the original Code Bubbles that was on the left there. They're static modular views of the system, which have these things in them. You can build them dynamically. Granted, the programmer right now has to build them dynamically by bringing up components. We give you a lot of help for doing that. The good search techniques, find all the definitions, find all the things that can be called virtually, find all references to this field, to this object. And then we have a number of modularization techniques to show the individual functions or components, each in a separate bubble. Use elision within those components to hide the parts that's not part of that function that's not relevant to your particular aspect. We allow you to have all different types of software artifacts, so you can have error displays, you can have notes, you can have documentation for external components. All that can be put up as part of the view here. And we allow these views to be saved and restored. So I can save it and come back to it later with a name, save it with a name, come back to it later, see it. I can also share it. I could send it as email to a colleague and have him work on that particular view. But this is only a start. I claim it is modularity, but it's not really sufficient. It is a good start. I really don't have a complete or a final solution. I'm not saying I know everything. Never say that. Approaches such as Code Bubbles, there's a number of problems here, let's put it that way. You can construct a simple editable modular views. If the code is reasonably modular, the view comes out. It works even if it's across multiple files, multiple systems, or different parts in the same file. It's very easy to put all the code up there. It still doesn't handle multiple languages. This is all Java right now, or all Python. There's no mixture of the two. It doesn't handle dynamics particularly well. I can't create that view I want for the squiggle problem. But all the necessary components is there. My sense is that virtual modularization, the type of thing I'm doing here, is the way to go. I don't say this is the ultimate way of doing that. But it works. It gives me modularity. It addresses large numbers of concerns. The other problem here is you have to actually edit. The programmer has to set these up. You'd like it to be a little bit better that way. Let's see, it's a static framework. Dynamic modularization is more complex. We've started to address these by trying to provide some dynamic tools, show you what's happening at runtime. You saw a little of that in the debugger. We have a few more coming online in the next few weeks or months, depending on how much I get the code versus how much I have to write. Let's see, what other problems are there? Program has to do a lot of work to come up with a decent display that's meaningful. You have to, if you want to connect these different components with lines, you can do that, but you have to manually connect them. If you want to have notes, you have to manually add the notes. They can be saved as part of the work environment or saved as on a line, but you have to do all that work. Now, I don't know how to create these views automatically, but if the program is willing to do a little bit of work, you can get the modular view. Given all these problems and looking at the dynamics, I think virtual modularization is the way to go, but I don't think there is a particular single solution that will work here. Prove me wrong. I hope you can. Let's see. This, right? Yeah, okay. So as a challenge, I ask you to attempt to address what it means to be modular in today's complex systems. It means addressing modularity with respect to real problems rather than just static code. It means coming up with appropriate modularization views on demand. So when I come up with a new concern or a new bug I want to fix or new feature I want to add, I can come up with a modular view that's particular to that. It means handling dynamics as part of modularity. I want to understand the dynamic behavior. The modularity should show the dynamic behavior. The modularity should reflect the dynamic behavior. It means handling systems that with today's modern systems, multiple processes, multiple threads, messaging, complex data, databases, black box portions of the system where you don't understand it, but it's part of what you have to deal with. Everything else in the program is tool bag goes into that. How do you handle all that in modularity? It's not just a simple program where you control everything these days. A real-life system has a lot more to it, and you have to modularize over all of that. It means making modularity practical and something that people actually can use as they deal with all these different problems. So I had some papers here, which you can, I like the titles. I don't know what half of them mean, but I like the titles. And with that, about 50 minutes.
So we have 10 minutes of questions and discussion time.
Yeah, so this is really hard. One thing that I think is worth considering carefully is why you could even think mentioning the division of a system into smaller parts as an obstruction to the modularity. So what is the underlying reason why different languages will make your system less modular?
So thinking of the web application, you know, the question is why does breaking it into smaller parts make the system less modular?
Yes. Seems it shouldn't be much worse than, okay, here's a modularization, but it can't possibly make our system less modular that we've now cut it into modules. But I think it's a very important insight that you've given us that this is the case, but could you make it more explicit? What's the underlying reason for that phenomenon?
Well, there can be several reasons. Statically, they might be separate, but when I would think of them, I have to think of them together. So I need to see them at the same time, and the fact that they're broken up just makes it more complex to work on them and change things because I have to change it in multiple places or I have to correlate my changes in multiple places. Dynamically, it's because I made all these little static pieces and they're all independent, but when you get to the dynamics and understanding dynamic behavior, these pieces are very dependent on one another, and if you make a change here, it's going to affect something over here in the dynamic behavior. And you really need to understand that for a lot of these debugging type concerns or what's going to happen with concerns or performance concerns or anything else that affects dynamics.
So basically what you're saying is that we have nice little chunks, but they're irrelevant because we need to think about little pieces of many of them.
Well, they're relevant for many things. They're relevant when you're writing the code because it's much easier to code in terms of those little chunks. But writing the code is only one small portion of software development. I don't spend much time writing code. I spend a lot of time fixing code or adding to code or understanding code.
So thank you for the really interesting talk. So like when you gave your definition of modularity and you were talking through this, like it seemed like your definition of modularity seems to fit more with, I don't know if there's like a specific term for it, but like what I call like this notion of like locality of code, like the idea that you have all the code for one specific execution in one spot. So I was wondering like, what do you consider, like, what do you call, like, our notion of modularity then, like this notion of breaking things up into submodules? Like, are you okay with presenting, this definition of modularity, which is effectively, like, seems to be the opposite of what we all think of as modularity?
Well, as I said here, that version of modularity is fine when I'm writing the code. Mm-hmm. And I showed you in the code bubbles code for type in. Yeah, I had all these little pieces of little chunks there. Mm. That's what I do. I break it into these understandable chunks when I'm writing it. It's just that when you're trying to do something later on, those chunks might not be that relevant.
Oh, okay. So it's like you have like this notion of modularity at like when you're writing, and then when you're actually debugging, you should be looking at it a different way, maybe.
Right. And okay. Different debugging concerns are going to yield different things you want to look at.
And in terms of the tools you're showing, like for bubbles, like, I guess it's for Java mainly, for example, for like.
Yeah, I have a version that sort of works for Python, but I don't tell anybody how to use it.
I was thinking, like, how intractable do you think is the problem of like trying to write those sorts of tools for dynamic languages? Because it's obviously a lot harder to do.
Well, as I said, we have it for Python. I just don't. It's about 80% there.
Okay. So you think it's
it's doable. There's certain things I have to figure out what it means. If it's a dynamic language, if I change something, do you want to have the output run dynamically, change automatically, or you want it like idle, so you actually rerun? What makes sense from a programmer's point of view, from the user's point of view? So I haven't done those user studies yet to figure it out. I can support either one.
Okay.
But I haven't done that. But I'd like to. I'm working on it.
Okay, and just one last small question. Like when you're showing bubbles, have you looked at this? I think last year somebody did a Kickstarter about it, Light Table, which is an idea that seems to be trying to do similar concepts.
I've looked a little at it. I don't remember it off the top of my head, but.
Oh, okay. Thank you.
Not enough to talk about, but I have seen it. Yeah.
The Eclipse editor was actually one of the case studies for our paper, so I can confirm that there is a lot of complexity there. And what we
have more because we're using the Java editing framework, and Eclipse at least understands end-of-line characters.
Okay. What we are actually trying to do now is to re-implement a prototype of that, a smaller prototype of that editor by using better language abstraction and trying to keep it more modular. But from your talk, it seems that if I understand it correctly, we should kind of give up with modularity, and modularity is more a matter of understanding a complex system from the right point of view, so that the system cannot be really modular. We just have the hope of finding a modular view of seeing at it. Can you comment on that?
Well, I think there is modularity, and modularity when you're writing code is important. If you write all your code in one big function, Code Bubbles is going to have a hard time giving you a modular view of that. If you write your code in little pieces, it's much easier for Code Bubbles to give you a modular, to construct the virtual modular views. It's great to have modular frameworks. I understand the Eclipse editor some. I understand all the Java. I understand the Java editing framework, which is impossible. And they violate their own modularity at times, which doesn't help matters. Their own hierarchies. There are things like abstract document, which it actually checks the type of when it's doing file locking. So you can't have. There's no lock document abstraction and things like that, which is what they need. But it would be helpful, if you construct and code modularly, it's much easier to use and write your own code. And writing is a big part of it. It's not everything. You still need to be able to see it later on. And there you need the different views of it. Having the modular first place makes it easier to do modular later on, though.
So one thing I was wondering is that you seem to see the runtime view is very important, and I would agree. So, but still then, when you say you have these code bubbles, you have basically a view of the static system, but with the runtime flow, because from this window I get to this other small piece of code, and from here I go to there. But it's still a static view, basically. And I mean, it does not tell you so much about what's going on at runtime. I mean, so do you think there should be even more, because like views that, for example, if you have multiple parallel programs, show you all the parallel processes in some way. I mean, you don't see them if you look at the code. You only see the code that will run at one thread or something.
Here are some of my dynamic views, which I haven't put into code bubbles yet.
Ah, okay.
Show what's going on inside the system. Some of these are coming in. This is memory view. So I am very concerned about this is locking behavior over time. What else we have here? That's at S6 and how threads and transactions go. This is the type of stuff I want in code bubbles. This is the type of stuff I need to have dynamically and be able to click on here and go to the appropriate source, or have the click on the source and see it highlighted here.
Okay.
So I have ideas for those views. I just haven't gotten that far yet.
So would you agree to the statement that we need actually to understand the system, what it does at runtime, are more domain-specific views for parallelism, for memory, for whatever type of domain you want to look at?
Yeah, if I had another half hour, I could get into that. Turns out what you need is just like modularity in these virtual views. If you have generic views, if you're just looking at memory, you're just looking at performance, you can only address generic problems. If you want to address the real problems, you have to modularize your dynamic views as well, and key the dynamic views to be key to the actual code. So this is actually looking at, in S6, at transactions in terms of the actual code, and it's colored by what phase of the program they're in. And this was actually done automatically, or mostly automatically. So you didn't have to do that. And that's what I want to do in code bubbles, is automatically generate these dynamic modular views that you can then tie to the code.
Thank you.